Okay, what I'm going to do is create a video of basically the most important notes that you'll find for an Algebra 2 class or a college algebra prep class or what I'm currently teaching, Math for College Readiness. It's all irrelevant what the title of the class is because these notes are going to be pretty awesome. And if you can follow what's going on for each one, and then most importantly, be able to apply it to later stuff, you're going to be set to go. There will be no question whatsoever. You'll have a good understanding of what's going on for functional analysis and algebra. So what we have is a set of 8 different equations, and what we're going to do is graph each of them. And we're only going to graph them by using a table of values, and that's going to fit with the early material that's being covered now at the beginning of the year. And then also, if you can understand basically the picture of each graph, then that's going to help you throughout the entire year. So we're going to dive in to study each individual one of these, but by doing the timeless trick, because it's going to last forever, it's always going to be useful, is to make the table of values. So you have your XY chart, and that helps you set up everything. And so the first equation that we're going to study is the basic y equals x. And of course, like I said before, we're going to create this by making a table of values. So we have to remember that a table of values is the good old XY table, and we have to recall how that works. Okay, that works by you choosing the x. Okay, so you choose the x values, but there's going to be a couple of I would say rules to kind of live by to make sure you're doing well. You want to choose enough x values you have a good idea of what the picture looks like. And I normally say choose 5 of them. And so we're going to choose 5 x values, 2 negative, 2 positive, and 0. And with that, you're going to be ready to have a really good grasp of what basically any picture looks like. So we have 2 negative values, 2 positive values, and 0. And all we do is our basic substitution piece and substitute our x with the x that we chose. So we chose x to be -2. There's the equation. There's the substitution. Of course, in this case, we will get back y equals -2. And we do the same thing for each of the x values that we choose and see the result. And hopefully you can tell that to complete the xy table, I'm going to skip a few steps to make sure that we see what's going on. Whatever I input for x, I'm going to get for y. Now what we do is take that table of values and sketch our graph. And we're going to see hopefully what the picture looks like, and we can have a good idea of what this picture or any equation that looks like it will look like. So you got to remember that each ordered pair is, of course, an ordered pair. So you can graph each one, and that's always helpful. So if I input -2 for x, I'll have -2 for y. If I input -1 for x, I have -1 for y. 0, 0, 1, 1, 2, 2. And this works for any input. So even if I created another one, if I wanted to say, what if x was 1/8, I could use fractions as well. Of course, my y would be 1/8, and that too would be a point on the graph. So notice, no matter what ordered pair that we can come up with, there's infinitely many. We just want to use 5 to get a good sense. There's infinitely many ordered pairs. So the set of all ordered pair solutions looks like that straight line. And that is the set of all ordered pair solutions is that graph. Okay? So the graph is the set of all ordered pairs that fits this. Now, no matter what that graph looks like, or what the equation looks like, if we have a y, we have an x, that's what the picture is going to look like. So I can do whatever crazy stuff I want to this equation. It's still going to look like the same type of thing. I could throw a number out in front. I can, take the x and maybe subtract some crazy number with it, and then, also add some number to the outside. No matter what I do with it, it's going to be a straight line. Okay, so the graph is going to look the same. It's going to look like some type of straight line. Okay, so I have the basic y equals x. It looks like this. But no matter what I do to the equation, it's going to be a straight line. Now you have actually seen a couple of forms that might look familiar, right? Slope-intercept form is going to make that straight line. And then we can also have something called standard form, but it still makes that straight line. You have a y, you have an x. That's all there is to it. You have a y, you have an x, that's nothing else. Y, x, y, x. It's going to make a straight line. And that's what that looks like. So we can use our table of values to go back to our original list of equations and realize if I have an equation that looks like this, I'm going to have y equals x. Okay? Now, what would happen if I had y equals negative x? Everything else would stay the same. It's just the line would go down the other way. Okay? So even if I had y equals negative x, it's still a straight line, but it's going down the other way. And that's how that behaves. So that's the basic behavior for number 1. What about number 2? We have a whole different equation now. For number 2, we have a whole different equation. Y equals the absolute value of x. And so what we'll do, again, is create that table of values. Remember, we're going to be the one that chooses the x, and we're going to choose a good x. Remember, we want to make 2 negative choices, 2 positive choices, and 0, so that we can have 5 ordered pairs. It'll give us a good sense of what we're doing, and we use our substitution piece. Remember, when we substitute, we're only switching out the x, okay? And the rest is number crunching. And so what will we get if we take the absolute value of negative 2? We will have positive 2. And if we take the absolute value of negative 1, we'll get positive 1. If we take the absolute value of 0, we get 0. The absolute value of 1 is 1. The absolute value of 2 is 2. So I have my set of ordered pairs. And no matter what number that I punch in for x, I'm going to get the absolute value of it for y. So once I have my 5 ordered pairs, I can create my graph. And graphing is better on graph paper, because you got to remember, if you're hand drawing stuff, just keep in mind this is your hand drawing. It might not be completely accurate. So we graph our ordered pairs. X is negative 2, y is negative 2. Negative 2, negative 2. X is negative 1, y is positive 1. I think I said that wrong. Negative 2, positive 2. Negative 1, positive 1. 0, 0. 1, 1, 2, 2. Okay, so I have this set of ordered pairs. Now, it kind of looks like a V, right? But just in case, what if I created, I can make it a whole nother ordered pair. What if I have x as, 1/3? What would y be? The absolute value of 1/3 is 1/3. That's also going to exist on the graph, right? So 1/3, 1/3. Here's 1/3. Here's 1/3. Hey, it's going to fit right along that V. So this graph is going to make a nice little V shape. So the set of all ordered pairs that makes this equation true looks like a V. No matter what I do to this equation, if I have the absolute value of x, I'm going to have a V shape. So no matter what I do to the equation, I could make it, some number out in front. I can subtract some number from the x. I can, add some crazy number to the outside. No matter what I'm doing to that equation, that's called vertex form, by the way. No matter what I do to the equation, I'll have a V. It's going to look like that V. Okay, so knowing this is a helpful piece of information. And so back to the original equation, what is this going to look like? Well, if we have the absolute value of x, it's going to make a V. What if I had the negative absolute value of x? It's going to look awfully similar, but it's going to be an upside down V. And so knowing that piece of information is going to be helpful for the entire concept of Algebra 2. And now on to the third equation. So now we have y equals x squared. And we'll perform the same process. We're going to make a table of values. And then we can choose some good values for our x. And then see what happens for y. We're going to substitute only the x. Okay, substitute only the x. Everything else remains the same. And now I have, in this case, of course, y equals negative 2 to the second power, which of course is positive, right? Negative 2 times negative 2 is positive 4. And then negative 1 to the second power is positive 1. 0 to the second power is 0. 1 to the second power is 1. 2 to the second power is 4. I have 5 ordered pairs. I'm ready for a graph. Okay, so hopefully you're seeing how that works. Once you get 5 ordered pairs, you're ready for a graph because you're going to get a good idea of what this thing looks like. So we can have a good sense of what that graph looks like for that equation. So now what we'll do is sketch our ordered pairs. We've got negative 2, 4. Here's negative 2. Positive 4 is way up here. We've got negative 1, 1, 0, 0, 1, 1, and 2, 4. Now this kind of looks like that V, right? Doesn't this kind of look like it's going to make that V? Well, let's be sure, just in case. We're going to pick another x value. What if I picked 1/2 for my x, right? So if I chose 1/2 for the x, will it fit a V? Well, if I chose 1/2 for x, you know what my y would be? 1/4. Because 1/2 times 1/2 is 1/4. And so I'd have this other ordered pair. 1/2, 1/4. Whoa. So that's definitely not a V, right? A V would go like this. This graph is kind of bending, making what we call a parabola. So we have y equals x squared, making some kind of parabola. It's called a parabola. This is called a quadratic equation. That is called a parabola. We'll get to the vocabulary later. And no matter what I do to this equation, I can throw an a out in front, some crazy number way out in front. Maybe I can take that x and subtract some number from it before I square it. And then after I'm done squaring it, I could throw another number out there. No matter what, that's called vertex form. It's still an x to the second power is going to make a parabola. That's called vertex form. I can also have it in what's called standard form. Throw some number out in front. That's in standard form, and it's still the same. X to the second power is going to make that shape. Okay, so anything x to the second power is going to make that U shape, that parabola shape. So I know that, right? So whenever I see y equals x squared, I'm going to make that parabola shape. So if I have y equals x squared, it's going to be a parabola, not a V. And at the same time, if I had a negative out in front of the x squared, it's not going to make a U. It's going to make the upside down U. Okay, so it's going to make a parabola opening downward. So I have the general idea of what that shape is going to look like. Now on to the next equation. Y equals the square root of x. Okay, so what's going to happen here? Some interesting things may start to happen. So we have y equals the square root of x because we're going to get into some math. We're going to do the same thing as before. We have an xy table. And now remember, we're going to choose our x's, but I'm going to make a note. We're going to choose our x's wisely. Okay, so we're going to choose wisely. Notice that we're dealing with the square root. So we have to choose a number for our x that's going to be friendly for a square root. Yes, we can choose 3, but what is the square root of 3? Some number that we have to estimate. You know, we could use 5, but what's the square root of 5? Again, some number we have to estimate. Why not use a number that we know? Okay, something like 4 or something like 1. Okay, so again, we want to use a couple positive numbers, a couple negative numbers. And then let's see some interesting stuff occurring. Now, for those of you that are already pretty good with math and algebra, hang tight. I'll catch up with you. You're ahead of me. Yes, you're right to be confused, but let's catch up. Now, we have our 5 values. Let's plug them in and see what we get. So we have y equals the square root of negative 4. Now, what in the world is the square root of negative 4? That's undefined. If you punch that in your calculator, boop, 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 you're going to get an error message. No way. That's undefined. So we can't have that, right? So undefined, we can't have that. So maybe the same thing will occur with plugging in negative 1. And you plug in negative 1 for x, you get y equals the square root of negative 1, which is a very famous number. This is famous, but also undefined. It doesn't exist in the real world. So it's not in the real world. It's not a real number, but it's a good famous number. We'll get to it later. Okay, so that's undefined. It can't happen. What about y equals the square root of 0? The 0 most definitely is defined. that is a number. We can point to it, and we can graph it. It's 0. And then we have the square root of 1, which is 1, and the square root of 4, which is 2. So we can do that. But let's not graph yet because I want 5 values. Okay, just remember, I want 5 values. So let's pick 2 more values. Can we take the square root of 9? Yes. Can we take the square root of 16? Yes. Okay, so I want 2 more values. Remember, we're the ones that are choosing wisely. So we choose wisely our next 2 x values. And of course, we can have our simple to graph y values. Okay, so we can see what this picture is going to look like. I have 5 ordered pairs. Now I'm ready for my graph. And once I have my graph all set up, I can start plotting down these ordered pairs. And let's see what's going on. So I have an ordered pair at 0, 0. I have an ordered pair at 1, 1. I have an ordered pair at 4, 2. Well, that's interesting. And an ordered pair at 9, 3, which is maybe somewhere out there. As you can see, this is not getting high very quickly. It's kind of getting high very slowly. So it almost looks like I don't know what's happening, but what if I threw a fraction in there? You know, what if I played around with another ordered pair? Like what if I had x being 1/4? What would then be the square root of 1/4? Of course, that would be 1/2. Okay, so I could graph 1/4, 1/2. It kind of looks like 1/4 is here, 1/2 is there, and there it's almost like the 1/2 of a sideways parabola, which is pretty much what it is. So we know that the graph is going to look like this. It's 1/2 of a side. Basically, knock a parabola down and cut it in half. And that's what that graph is going to look like. That's what the square root of x does. Okay, so that's the impact the square root of x does. And no matter what I do with that equation, I can throw some number out in front of the symbol. I can, take that x and then subtract something weird with it. I can, outside of it, add some other number. No matter what I'm doing with that equation, I can always know that if it's a square root of x, I'm going to have some kind of graph that behaves this way, okay? And that's helpful to know. So I know from the main thing that if I have, again, the square root of x, I'm going to do something like this. So what would happen if we had the negative square root of x? Very similarly, okay, but this time all the outputs are going to be negative. It's going to go something like this. Okay, so I know that if I have a graph that looks like that, that's because of that square root of x. Moving on to the next one. Okay, so now we have another kind of crazy looking equation. This is bizarre, but we're going to trust the process and see what happens. And again, if you can follow this and you can understand and know this, like in your heart of hearts know this, you are going to be cruising in any type of algebra class. So we have another equation that we got to deal with. Again, we choose our x values and y values, and we can do 2 positive values, 2 negative values, and 0, and see what goes on. And again, for those of you that have an idea of what's happening, do chill. I'll get there. So now we substitute what we know. So if we plug in -2 for x, well, of course, we're going to get -1/2 for y. And if we plug in -1 for x, we're going to get -1 for y. Okay, so that's, I should use different color, but it doesn't matter. What happens if we plug in 0 for x? 0 for y? No, not 0 for y. Plug that into your calculator. 1 over 0, what is that? That is undefined. You cannot divide by 0. You can't chop something into 0 equal parts. That doesn't make any sense. So that is undefined. You can't divide by 0. You can't cut something into 0 equal parts. It makes no sense. So if 0 is undefined, we have to do something else. And I'll show you another trick. Now what if we plug in 1 for x, we have 1 for y, 2 for x, 1/2 for y. So what do? I need another point. What if I picked a fraction for x? Mr. Katz, fractions, I know. What happens if I make 1/3 for x? What's going to occur? I'll have y equals 1 over 1/3. 1 over 1/3? That's crazy. What's a different way of saying 1 over 1/3? You say it a different way, 1 divided by 1/3. And now we're back into some basic elementals. If 1 divided by 1/3 is the same as 1 times 3 over 1, Guess what that is? 3. So if I plug in 1/3, I get 3. If I plug in 1/3 for x, I get 3 for y. And same thing happens if I plug in negative 1/3 for x, I get negative 3 for y. What's going to happen with that graph? Now I have actually 6 ordered pairs, but I have enough I have a good idea of what this picture might look like. And this is a pretty cool picture. It's called a rational function. And rational functions are fun, I think. Then again, I think all this stuff is fun. All right, so anyway, we're going to sketch our graphs. -2, -1/2. -2, -1/2. -1, -1, -1, -1. 0 is undefined. We're not plotting 0. 1, 1, 1, 1. What's going on here? Am I going to be... This is weird. And then 2, 1/2. 2 1/2 is right here. This is so strange. Do I connect the dots? You know, what's going on? Well, it's a good thing we picked these numbers, because look at what's going to happen. 1/3, 3. Here's 1/3. Here's 3. Whoa! Look what's happening with this graph. What if I just guessed something? What if I picked, a number like 10? Oh, I'd get 1/10. So if I pick a number like 10, I get 1/10. That's like way out here, really low. I also had negative 1/3, -3. Here's negative 1/3. Here's negative 3. Wow. Wow. And the same token with that 10, 1/10, I can also do negative 10, negative 1/10 to be something really low. So now I see what's happening with this graph. And that's the whole point. If you can follow this, boy, oh boy, are you set to go. And we're only in the, in the beginning of the class. So you can tell that if I have 1/x, my x is in the denominator, okay? So notice that x is in the denominator. I have a funny looking graph, a rational function. That means the graph is going to behave something like this. As x gets bigger, y does some strange stuff. Okay, so that's what that graph looks like. So if I have y equals 1/x, that's what the picture's going to look like. And now I have studied that. So if I have y equals 1/x, my graph is going to look kind of weird. And at the same token, if I call that a negative, y equals negative 1/x, it's going to be quite the flipperoo. So it'll look something like this. Okay, and that's just in general. In general, you have a good idea of what rational functions look like. And now on to the next one. This is where stuff gets fun. We actually talk about this. You hear these words all the time because people say them without knowing what they mean. And I think the number of people that continues to say this word without knowing what it means is growing exponentially. This is an exponential function. People say exponential growth. They don't know what it means. But anyway, this is what it means. We're going to pick a table of values and do the same thing as before. Choose our x values. -1, -2, 0, 1, 2. Then we're going to see what happens with y. So we substitute what we have. Y equals 3 to the -2 power. 3 to the -2 power? What? That's crazy. I'll get back to that in a second. Let me go with something I know. I know y equals 3 to the 2nd power. Yeah, buddy. That much I know. I know y equals 3 to the 2nd power. That's 9. See, that's kind of cool. You know what? And to make a teaching point, just in case, what if I had y to the 3rd power? Hopefully you know what that means. 3 times 3 times 3, right? 27. So I have y equals 3 to the 3rd power is 27. Y equals 3 squared is 9. How about this? Y equals 3 to the 1st power. Notice what's happening. 3 to the 3rd power is 27. Divide by 3, I get 9. Divide by 3, I get 3. Then I have this. Y equals 3 to the 0 power. Divide by 3 to get 9. Divide by 3 to get 3. Divide by 3 to get 1. Anything to the 0 power is 1. So hopefully you can remember that. So what would happen if I had y equals 3 to the -1 power? Okay, so again, we're going to see the pattern of what's happening. 27 divided by 3 is 9. Divide by 3. Divide by 3. Divide by 3. What's 1 divided by 3? 1/3. And now I'm ready to do this one, right? 1/3 divided by 3, 1/9. How cool is that? Okay, so now we can handle negative exponents, but we'll do more with that later. Either way, now we have enough ordered pairs to sketch a pretty cool graph. And so we're going to do just that. So we're going to sketch a pretty cool graph and see how our behavior is going. Okay, so let's see what this equation looks like. It's called an exponential function. So if we have -2, we get positive 1/9. Here's -2. Positive 1/9 is awfully close to 0, right? So it's right there. If we have -1, we have 1/3. So -1, 1/3. It's close to 0, but not as close as 1/9. If we have 0, we get 1. If we have 1, we get 3. Whoa, look at that. If we have 2, we get 9. It's like way up there. Holy cow. So what's happening with this graph? What's happening with this graph is it's growing exponentially. That's why we call it exponential growth. Anywho, not the point. This graph just gets really high really, really quick. Okay? And no matter what we do, we can see that if the graph has the x in the exponent, exponential, if the graph has the x in the exponent, we know that the picture is going to look something like this. It's going to get really high really quick. Okay? So now we know what that looks like. So this graph is going to get really high really quick. And if that 3 was a -3, what might happen? It's going to get really low really quick. Okay? So that's what's going to happen with that. So now we know what those graphs look like. Okay? And the last two are kind of fun because they're really, really important. Okay? So we have y equals 6 and then x equals 8. All right, so the first one, y equals 6. Again, we're going to make our xy chart. See something cool that happens. So we're going to choose, right? We're going to choose values, or are we? Because take a look. The equation has already chosen. So we have already chosen our y because the equation reads y equals 6. So guess what? The y coordinate has already been set for us. This tells us the y coordinate is 6. So no matter what, the y coordinate is 6. So no matter what, the y coordinate is 6. Doesn't matter what we choose for the x coordinate, the y coordinate is going to be 6. And so we can stick to our basic x coordinates, -1, -2, 0, 1, 2. It doesn't matter what we choose, the y coordinate is going to be 6. That's what that means. Okay, so we're going to do just that. We're going to graph just that. Okay. So now we sketch our graph. If I have x is -2, y is positive 6. 1, 2, 3, 4, 5, 6. Yeah, close enough. If x is -1, y is 6. I was off. Oops. I can count. Don't mind those. If x is 1, y is 6. If x is 2, y is 6. No matter what, the y coordinate is 6. So don't mind those two things. I just made a boo-boo. But hopefully what you can see is that no matter what my x coordinate is, my y coordinate is always going to be 6. Let me just fix that for you. If you copied that down, just fix it. It's at 6. So this is going to make a horizontal line. It's a special kind of line. Okay? So no matter what happens with an equation, if you notice in this equation, there's only a y. There is no x in the equation. And it doesn't matter about the number 6. I can call it y equals, it doesn't matter, any constant number. And we call that k. Okay? K stands for constant. Any constant number. Okay? So no matter what, we have a constant number and there's no x. That is a horizontal line. Okay? And that is a great note. So no matter what, if we have y equals 6, it's going to be a horizontal line. Okay, so now I know. If I have y equals 6, horizontal line. And guess what? If I had y equals -6, still a horizontal line. Ain't going to matter. It's a horizontal line. There's no x, right? And now for the last one, and then you'll have the notes that will set you up for life in algebra anyway. X equals 8. Okay. So we have this last equation, x equals 8. We're going to do the same thing we've done before. Table of values. And so we have this table of values. And guess what? The x coordinates are already chosen by the equation. So the x coordinates are already chosen by the equation. The equation reads x equals 8. Guess what? X is 8. So of all of the ordered pairs that we are dealing with, the x coordinates are 8. All we got to do, choose some y coordinates, and we're set to go for the graph. We'll have a good idea of what this picture looks like. I would hope you already know, but whatever. So we make our coordinate plane, 7, 8. And then we start sketching our ordered pairs. Okay, so we have 8, negative 2. Here's 8, negative 2. We have 8, negative 1, 8, 0, 8, 1, 8, 2. No matter what I have for x, is always going to be 8. My y can be whatever it wants. This y can be whatever it wants. The x coordinate will always be 8. Okay, so my x coordinate is always going to be 8. And that's every single ordered pair that has an x coordinate of 8. So look at the equation then. If we look at the equation, it only says x equals 8. There is no y in the equation. And it doesn't matter what I call that number 8. I can call it any number whatsoever, any constant number. So if x equals any constant number, I'm going to have a vertical line. And that's always going to happen. So how cool is that? So if I have x equals something, I'm always going to have a vertical line. So take a look at this last chart. X equals 8, vertical line. Well, what if we had x equals negative 8? Still, x equals some constant number. It's going to be a vertical line. And all of these graphs are going to be used throughout the year. And so we have a good idea of what they look like. And if we can't tell what they look like, we'll make a table of values and we'll figure out what they look like. But if you can do this and you can do it quickly and access it, you are set to go. I guarantee you're going to pass. That's why I call them guarantee pass notes. So thank you so much for your patience. That was a bear. I will talk to you in class.